Hello everyone. We are now going into a lecture on chapter 1.5, which is titled More on Slope. Now the previous section of chapter 1, that's 1.4, is also discusses slopes, but it talks about the basics of slope, but we don't cover that in the syllabus. 1.4 is not a part of the pre-calculus syllabus because it's some basic stuff which you're already supposed to have learned in a previous algebra course. So we assume that you know the basic stuff. If you need to review the material, please read it up on your own. And there are also some videos on MyMathLab. You may want to watch those as well. We are going to talk about the slopes and equations of parallel and perpendicular lines. Then we are going to go into slope, how to interpret the slope as rate of change. And then we are also going to find a function's average rate of change. So first we are going to talk about the rate of change before we talk about the average rate of change. But we are going to start by talking about parallel and perpendicular lines. And just to remind you, parallel lines are two lines. Okay, parallel lines are two lines, or could be more than two lines also, but lines that do not meet, they never meet. That's the property of a parallel line or parallel lines. Okay, so we are going to talk about the slopes of these two lines, how they relate. Okay, there's a relationship between the slopes of parallel lines, whether they are two lines or three lines or multiple, more than three lines. There's a special relation between the slopes. All right, so that's about parallel lines. And then perpendicular lines are two lines that intersect, that meet each other at right angle. Right angle meaning 90-degree angles. All right, two lines that meet each other at right angles, they are called perpendicular lines. And again, there will be a relationship between the slope of the perpendicular lines. We will go into that, and also how to come up with equations of parallel and perpendicular lines. Now, just to go into the basics of slope, I did tell you before that 1.4 talks about the basics of the slopes of a line, which you're supposed to know, or you're supposed to read on your own if you've forgotten about it. But I'll just review it very briefly. The slope of a line tells us how much a line slants up or slants down. Basically, it tells us how much a line rises up or falls down, as the case may be. Slope of a line is denoted by the letter M, all right, and we can quantify, we can find numerically a numerical value for the slope of a line if we are given 2 points on a line. If we are given any 2 points on a line, we should be able to find the slope of a line, again denoted by the letter M. So all we need to find the slope are 2 points, and let's denote that the 2 points, the coordinates of the 2 points, as x1 comma y1 and x2 comma y2. Okay, so these 2 points, let's say, are given to us. Once we have the coordinates of the points, we apply those values into a formula, which is y2 minus y1 divided by x2 minus x1. Okay, In other words, this formula, or the slope of a line, tells us how much a line rises or falls, as we move horizontally along the line. All right. So it's also sometimes in layman's terms denoted as rise over run. Okay. The y-axis in the coordinate system, we have the x-axis and the y-axis. X-axis is a horizontal, where we move horizontally along the x-axis, correct? And on the y-axis, we move vertically up or down. Okay, along the y-axis, we move vertically up or down, and along the x-axis, we move horizontally right or left. Okay, so the slope tells us how much the rise is, how much we go up, maybe as we move along horizontally from left to right. All right. So that's just an introduction to slopes, but we are going to jump into discussing the slopes of parallel and perpendicular lines in the next slide. Now this slide talks about the relationship of the slopes of parallel lines. Okay, so I'm going to read through it. It says, number one, if two non-vertical lines are parallel, then they have the same slope. Okay, so if we have two lines and we are told that they are parallel, then whatever the slope of line 1 is, of the first line is, any other line parallel to that line, whether it's another line or 3 or 4 or 5 or 100 lines, as long as they are all parallel to each other, they will have the same slope. Okay, so slopes of parallel lines are equal, are the same. Conversely, number 2 says if two distinct non-vertical lines have the same slope, then they are parallel. All right. So if we are told that two lines are parallel, we can conclude that, all right, their slopes are equal. Their slopes are the same. If line 1 has a slope of 3, then line 2 will also have a slope of 3. If line 1 has slope of half, then the parallel its line, the line parallel to it will also have a slope of 1/2. Conversely, if they don't tell us that the lines are parallel, but they tell us the slopes of the two lines and they are equal, then we can conclude that the lines are parallel. All right. Number 3 says two distinct vertical lines, both with undefined slopes, are parallel. So we can have vertical lines too, but vertical lines, keep in mind, their slopes are undefined. Okay, vertical lines that go straight, I'm sorry, it doesn't look too vertical, the line I'm drawing, but lines that go straight up or down, okay, lines that rise up or down straight, vertical, perpendicular to the ground rather, they are vertical lines. They will always have undefined slopes. All right, they will always have undefined slopes. But even though their slopes are not defined, if there are two lines with undefined slopes, we can conclude that they are still parallel. All right. Now here we are told how to write equations of a line parallel to a given line. So it says here, write an equation of the line passing through -2, 5 and parallel to the line whose equation is y equals 3x plus 1. So they have given us the equation of one line, which is y equals 3x plus 1. So let's say, and I'm not able to draw too well, but let's say this is line 1. Okay, line 1. All right, and then there is a line parallel to line 1, and we'll call that line 2. All right, now this equation that they have given us is for line 1. Okay, this equation that they have given us is for line 1. And the point that they have given us here, this point minus 2 comma 5, is a point on line 2. Okay, let's say here's the point. It's a point on line 2. So this point belongs to line 2, but this equation that they've given us is the equation of line 1. So given this information, they are asking us to write the equation of the second line. All right, write the equation of the second line, which has a point minus 2 comma 5 somewhere along the line. Okay, and is parallel to L1, which has an equation of y equals 3x plus 1. Okay, so let's see how they go about doing this. It says here, express the equation in point slope form. Again, where if you've read chapter 1.4, you will remember, or from a past class, you will remember that the form of the point slope is y2, or let's put it this way, y minus y1 equals m times x minus x1. All right, so y minus y1 equals m, which is the slope, times x minus x1. This is the point slope form. It's called the point slope form because it has the slope, it has information on the slope and a point that we are going to use plug in here. All right, so it says express the equation in point slope form. So we have been given a point minus 2 comma 5, so we are going to plug in minus 2 where x1 is. All right, minus 2 is the x coordinate, so we are going to plug in minus 2 into x sub 1, and we are going to plug in 5 into y sub 1. However, how do we find m? All right, we need to find m. Once we find m, we will be able to fill in this equation, this form of the equation, and we'll be done. Okay, so we are just waiting to know what m is. Now, as you see over here, y equals 3x plus 1 is given to us in slope-intercept form. All right, so let me write that. And so the slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. That means the point where the point on the y-axis where the line intersects the y-axis. It's a y-intercept. Okay, the b. So since the equation given to us is 3x plus 1, 3 is going to be our value of the slope. 3 is the slope of line 1. And because the lines are parallel, we can use the same slope value for line 2 as well, because remember, by the slope property of parallel lines, they will always be the same for parallel lines, right? The slope will be the same for all parallel lines. So if line 1 has a slope of 3, then line 2 is also going to have a slope of 3. So now all we do is we keep one set of the x and y variables in the equation, because equations must have an x and y variable, all right? Otherwise, it's not an equation. So what we are going to do is we are going to keep the y as it is. So y minus, for y sub 1, I'm going to put in minus 2, minus 2. So y minus minus 2, because, I'm sorry, I made a mistake here. So I'm going to correct myself. It's y minus, what is the y coordinate given to us? The y coordinate is 5, not minus 2. All right, be very careful about that. I just made a mistake here previously. So use 5 for y sub 1. All right, so y minus 5 equals 3 times x minus, now we use the minus 2. All right, x sub 1 is minus 2, and I'm going to surround minus 2 in brackets, because that is going to remind me that minus times minus is going to become a plus. All right, so let's see how they have worked this. It says express the equation in point slope form. Y equals 3x plus 1. The slope of the line is 3. A parallel line will also have slope of 3. And then they plug in the coordinates of the given point into the point slope form. So y minus 5 equals 3 times, same thing that we did here, x minus, and they too have surrounded this in brackets, minus 2, which is the x coordinate given to us. And then this will be rewritten as y minus 5 equals 3 times, minus minus becomes a plus, so 3 times x plus 2. So in point slope form, the equation of the line is y minus 5 equals 3 times x plus 2. All right, so this is how we write the equations of a parallel line using the slope property of parallel lines, the particular rule, the relationship of slopes between parallel lines, when we are given a point and the slope of another line. Okay. Now we talk about the slope of perpendicular lines. Again, the perpendicular lines intersect each other at right angles. Okay. So it says if two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of the slopes of two lines is -1, then the lines are perpendicular. And then it says a horizontal line having 0 slope is perpendicular to a vertical line having undefined slope. All right. Now, what this essentially means, all right, that the product of their slopes is -1. It means that the slopes of perpendicular lines are negative reciprocals of each other. Okay, I'm going to write that down. Negative, and then I'm going to explain what that means. Negative reciprocals of each other. So what that means is if line 1, so we have two lines intersecting at right angles, L1 and L2, all right, L2. Now, if line 1 has a slope of 1/3, 1/3, then line 2 will be its negative reciprocal. Now, what does reciprocal mean? Reciprocal means that it's the inverse of each other. That means in the reciprocal of a number is when we flip the numerator and the denominator. So the reciprocal, let me do that separately in case some of you are lost. The reciprocal of 3/1 is 1/3. You see what I mean? We flip to create a reciprocal, we flip the numerator. Okay, we flip the numerator and the denominator. Okay, what was in the numerator goes in the denominator, and what was in the denominator goes to the numerator. All right, that's how we create reciprocals. All right, and negative reciprocals mean we just put a negative sign, all right, to the reciprocal that we formed. So if L1 has a slope of 1/3, then the negative reciprocal, first of all, the reciprocal of 1/3 is you flip the numerator and the denominator and it becomes 3/1. And all you do is put a negative sign to it. All right. Now, when you multiply these two slopes, you will come up with a value of -1. All right, it'll come up with a value of -1. So let's just do that. 1/3 multiplied by -3/1. What happens? 1 and 1 divides, 3 and 3 divides, right? So we end up with -1. Okay, so that's the relationship between the slopes of perpendicular lines. Similarly, let's take another value for slope. Let's say L1 has has a slope of -2/5. Okay, then L2 will be the negative of -5/2. How so? The reciprocal of -2/5 is you flip the numerator and the denominator. So the 5 goes to the numerator and the 2 goes to the denominator. The minus sign is there, correct? So we got the reciprocal of -2/5 as -5/2, and then it's the negative, because I said it's the negative reciprocal, so it's negative of -5/2, which makes it a positive. Negative negative becomes a positive, so it becomes +5/2. Now let's do a quick check to see if when we multiply L1 and L2, whether we are getting negative 1 or not. All right, they should multiply and give us -1. So I'm going to take -2/5, which is the slope of the first line, and then multiply that by the slope of the second line we just found, which is +5/2. So 5 and 5 divides, 2 and 2 divides, and we are left with -1 times 1 is -1. All right. So that's how we check for the slopes of perpendicular lines. The slope of perpendicular lines are negative reciprocals of each other, which when multiplied will give us a value of -1. And also keep in mind that perpendicular lines, if one line has a negative slope, the other line will always have a positive slope. Okay, one will be a negative, the other one will be a positive in case of perpendicular lines, whereas in parallel lines the slopes will be exactly the same. All right, if one line has a negative slope, the other line will also have the exact same negative slope. If one line has a positive slope, then its parallel line will have the same positive slope. Now here's an example of finding equations of a line which is perpendicular to a given line. Okay, so it says here, find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 equal to 0. So they've given us the equation of one line and they want us to find the slope of a line which is perpendicular to this line here of the given equation. So since we know now that there's a relationship between the slope of perpendicular lines, that means the slopes of perpendicular lines are negative reciprocals of each other. If we can find the slope of this line of this given equation, then we can apply our knowledge of the relationship of perpendicular lines and find the slope of the perpendicular line as well. So let's see how how we go about it. All right, I'm going to work here separately, although they've done the work here. All right, I'll do a similar work, but it'll be easier for you to follow as I'm working. All right, now this equation, okay, the best way to find the slope of a line is by putting it in the slope-intercept form. Okay, so what is the slope-intercept form? It's, okay, the slope-intercept form is y equals mx plus b. So if we can transform the given equation in this slope-intercept form, then we can just look at the value of m and get the slope of this line. Currently, the way it is, it's not possible to figure out the slope of the line. All right, so let's work on isolating the y, having it by itself, keeping it by itself on one side and getting everything else over to the other side. That's the way we derive the slope-intercept form. Okay, so here we have x plus 3y minus 12. So step by step, I'm going to move the items over to the other side. So I want to keep the y by itself. So let's put the 3y here. I'm going to move the x over to the other side. So 3y minus 12 equals, if I move the x to the other side, it becomes a minus x. Whenever you move a variable or a value in an equation from one side to the other, you have to change its sign, correct? So we have got 3y minus 12 equals minus x. Now we have to move the minus 12 over to the other side. So we have 3y equals minus x plus 12, correct? And now we want the y by itself. We don't want the 3 left here with the y. So what do? We divide both sides by 3 and we get y equals minus x over 3 plus 12 over 3. Okay, we divide both sides by 3. So 3y divided by 3 is y, minus x divided by 3, and then plus 12 divided by 3. So this will yield a 4. All right. So I'm going to look at what the way they have worked here on the slide. So they have x plus 3y minus 12 equal to 0. They got 3y on one side, on the left hand side, and moved the x over to the other side, and it became a minus x. And then they moved the minus 12, just like we did here. They moved the minus 12 over to the other side, it became a plus 12. And now, and then in the next step, they divided, okay, they divided all the terms by 3 to get rid of the 3 with y. So we are left with y equals negative 1/3 x plus 4, and we got the mx plus b form. So minus 1/3, the coefficient of x, is what the slope is, m. This part is the m. So minus 1/3 is m, right? So we, at this point for this problem, we don't care about the intercept here. We don't care about the 4. All we need is the minus 1/3 to figure out the slope of the perpendicular line. It's going to be the negative reciprocal of negative 1/3. So again, let me write that down. It's the negative reciprocal. So we have negative 1/3. Line 1 has a slope of negative 1/3. So line 2 is going to be negative of the reciprocal of negative 1/3. So to form the reciprocal, what do? We flip the numerator and the denominator. So it's going to be negative 3 over 1, correct? So L2 is negative and negative. Negative multiplied by negative is a positive. So we end up with positive 3. 3 over 1 is the same as 3. So the slope of L2 is positive 3, and that's what they've written here. Okay, the slope of any line perpendicular to this line is 3. That's how we got the value, right? Now we will talk about the slope as rate of change. So one way of perceiving the slope of a line is also called the rate of change. Rate of change means how fast the y values change as we move along the x values of a line. Okay, so it says here slope is defined as the ratio of the change in y to a corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable, and dependent variable being the y variable, per unit change in the independent variable, which is the x variable. All right. So essentially, what it says is how quickly, how fast are we rising up as we move along the horizontal axis. All right. So if we go back to the formula for a slope, it's m equals y2 minus y1 divided by x2 minus x1, correct? Where x1 comma y1 are one ordered pairs on a given line, and x2 comma y2 are the ordered pairs of a second point on the line. So if we have a line going like this, then, and we take 2 points here, one around here and the other one around here, okay, and let's say this the first, the bottom point is denoted x1, y1, and the coordinates of the second one is x2, comma y2. Then when we find the slope, it tells us as we move, all right, as we move along the x-axis horizontally, how much does uh, how much is the change in the y values? Essentially, that's what the rate of change is. And look at these two lines. We have this line which has a certain slope, a certain slant, but if we take another line, okay, and I'm going to make it a little more steeper. Okay, I'm going to make it, I think it doesn't compare too well, so I'm going to erase this and draw another one here. Okay, I'm going to make it look like this. Okay, as you will note, and I'm going to take 2 points on this line. Okay, and we can see here that the blue line slants steeper than the red line, correct? The rise in the second line, the red line, is more gentle. The slope is more gentle. It rises slowly than the blue line, all right, as we move along the x-axis. This rise is steeper, is higher than the rise in the red line. All right. So the rate of change, slope as a rate of change, tells us how much, how fast the y value changes with respect to the change in the x values. Okay. Let's look at an example of the slope as a rate of change. So it's a word problem. I'm going to read through it first. It says in 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. Use this information to find the slope of the linear function representing adult men living alone in the United States. Express the slope, correct to 2 decimal places, and describe what it represents. So the first step is to put them together in ordered pairs. Okay, so we have the year, our x value here is the year, all right, that we are talking about. So 1990 and 2008, these are our x coordinates, and 9 million and adults and 14.7 million, these are the y coordinates. And with 1990, it's 9. So in 1990, when x, the year, was 1990, then the number of adult men living alone was 9 million. So they've put that as an ordered pair together. So 1990, comma 9. And then in 2008, which is the x coordinate of the other ordered pair, in 2008, the y value, which is the number of adult men living alone, was 14.7 million. All right, so 2008 comma 14.7. So the first step is to put together two ordered pairs from the information given in any word problem. And this says use this information to find the slope of the linear function. So now that we have two ordered pairs, and that's all we need to find the slope of any line, so we will use the formula. Okay, let's use the formula for slope, so it will be m equals y2 minus y1 divided by x2 minus x1. So let's mark these as x1 y1 and x2 y2. And what we'll do is we'll plug in the values. Again, in the numerator, it's always the y values, all right? So 14.7 is the value for y2. 14.7 minus 9, all right, 9 y1 divided by x2, 2008 minus 1990, and then we do the calculation and we will come up with a slope. So in the next slide, okay, they do the calculation. Let's go over that. Okay, using the ordered pairs 1990 comma 9 and 2008 comma 14.7, they did the same thing here. Y2 minus y1 was 5.7, 2008 minus 1990 is 18, and when we do the calculation on our calculators, it approximately comes to 0.32 million. Okay, and the way we express that, that means how fast has the number of men living alone in the United States changed since 1990, from 1990 to 2008. So the number of men living alone increased at a rate of 0.32 million per year. Okay, so every year from 1990 to 1991, it increased by 0.32 million. Then from 1991 to 1992, it increased by another 0.32 million. So that was the rate of growth in the number of adult men living alone in the United States. So the rate of change is 0.32 million men per year, and per year represents the unit change in the x values, in the x coordinate. In this example, it's the year. As we moved on from one year to the next year, the number of men, the change in the y value was 0.32 million. All right. Okay, now here we are going to talk about the average rate of change of a function, how to express the average rate of change of a function in general terms of a function. So remember, we express functions, we denote functions with this notation f of x. And what does f of x represent? It is nothing but the y value, right? F of x represents a y value. So another way of expressing the y value is using this notation f of x. It just tells that y, the y value, comes from an equation which is a function, all right? So we know that the slope of a line is y2 minus y1 divided by x2 minus x1. So when we are working with functions, we, instead of using y2 minus y1, we can replace these y2 and y1 notations as f of x sub 2. I'm going to erase this. X sub 2 minus, replace the y1 with f of x sub 1, all right? And rewrite this as f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1. All right, so if we are not given the ordered pairs, we are just given the x values and an equation, all right, then we can find the corresponding y values by evaluating f of x sub 2 and f of x sub 1 because those are nothing but the y2 and the y1 values. And once we find those values, we plug it in into this formula for m, and we can get our slope, which will also represent the average rate of change of a function. Let's go through an example to find the average rate of change of a function when we are given the equation of the function and two x values. All right, we are not given the specific y value for y1 or for x1 or the y value of x2. We are not given y1 and y2. We are given two x values and the corresponding equation of the function. But like I said before in the previous slide, in order to find the y values, all you have to do is evaluate this equation for x1 and then for x2, and you'll get the corresponding y values. So let's do that here. Okay, we need to find y1, correct? So y1 is the same as f of x sub 1, which is f of, how much is x1? Minus 2, right? F of minus 2. So we are going to plug in minus 2 into x in the equation x cubed, and we will get a value. So y1, which is also f of x sub 1, is going to be negative 8, right? Negative 2 cubed is negative 8. As for y2, which is going to be the same as evaluating f of x sub 2, which is x sub 2 is 0, right? So f of 0 is going to be 0 cubed, which is 0. So y2 is going to be 0. So f of x sub 2 is f of 0. All right, here f of x sub 2, f of x sub 2 is what y sub 2 is. So that's 0, and minus f of negative 2 is going to be negative 8. So here we have 0 cubed minus minus 2 cubed. So it's going to be 0 minus minus 8. So minus minus 8 is 8, positive 8, divided by 2 is 4. All right, so that's the slope or the average rate of change of uh, of this function x cubed.